This is feedback for the Unit 7 summative. I will be showing feedback for one of the versions. There are many versions that you guys took, so just go along with it. You might find a particular element that was not yours, but the format is all the same. So I will go through each problem, and you can compare how you did with the correct answers. Note that this summative was not graded on Google Forms, and you will find the grade in two different rubrics, both of them on PowerSchool. So those grades either have been entered or will be entered shortly once I get all the submissions. So here we go, feedback, Unit 7 summative, atomic structure. So we start with a diagram model of the atom, and our first questions all pertain to diagram number 1. So on this version, you can find A, B, and C, pointing to these different structures within the atom. Question 1, which letter in diagram 1 represents a proton? That would be letter B. Letter B, pointing to the positively charged subatomic particles in the nucleus of the atom. Which letter in diagram 1 represents a neutron? That would be this green structure over here, which is letter C. Neutral, neutrons. And an electron that is way out here on the edge of the atom, that is A. Which of these applies to a proton? I awarded a lot of partial credit here because it was a little hard to get all the points, but let's go through each choice and just kind of discuss that. So applying to a proton. Number one, protons have mass. And that mass matters. When we talk about the mass of an atom, protons contribute to that mass. You cannot have two atoms of the same element with different amount of protons. This is a unique amount to each element. So atoms have a unique amount of protons. If you were to add a proton to hydrogen, you would not have hydrogen anymore. You would have helium. We already talked about protons having a positive charge. So in terms of a proton, these three choices are the only ones that apply. Negative charge, no. No charge, no. So protons have mass that matters, a unique amount to each element, and a positive charge. A neutron also is in the nucleus, also has mass that matters. However, isotopes, we talked about isotopes, can have the same element but different amount of neutrons. So you can have, it is not unique amount to each element. Elements can have different amount of neutrons. Carbon, some carbons have 6 neutrons, some have 7, some have 8 neutrons, but it's still carbon. Positive charge, no. Negative charge, no. No charge, yes. So to review, neutrons have mass that matters, a unique amount to each element, and have no charge. That's for full credit on this question. Electrons do not have mass that matters. Yes, they have some mass, but very little mass. It doesn't matter. We don't even count it. Unique amount to each element? No, because as we know, ions can have different amounts of electrons, but still be of the same element. Chlorine can have a certain amount of electrons, or it could have one more if it acquires one and becomes the chloride ion. So it is not unique amount to each element. And it's a negative charge. So electrons, the only check mark here is for a negative charge. Diagram 2, this is where you might see some differences. This is the beryllium atom, And it's just us in these next few questions dissecting this picture. So first of all, the mass number of this beryllium atom, you have to choose the larger number up here, tucked in the upper left-hand corner, the number 9. Atomic number, down here, number 4. How many protons does the atomic number have? Well, if the atomic number is 4, that's the exact same thing as the amount of protons. Also number 4. How many neutrons does beryllium have? Well, if we look here, this is the mass number, this 9. So if the mass number is 9 and there are 4 protons, then there needs to be 5 neutrons because 4 plus 5 is 9. So how many neutrons does beryllium have? 5. Diagram 3, blank periodic table. This one I actually went in and looked at your responses. So you had to pick, based on this description, where does this atom go? So let's read the description of this mystery atom. So we know that this mystery atom has 1 valence electron. Oops. Oh, we'll just go on this. Has 1 valence electrons and over 10 protons. All right. If it has 1 valence electron, that means 1 electron in the outer shell. So this, it could only be A or B. It could not be C or D. This C has, I believe, 6 valence electrons, and this D has a full shell, 8 valence electrons. But since it's in the first group, it could be either A or B. So we got to go to the second clue. It has over 10 protons. Well, A does not have 10 protons. Look how many it has. If we're counting across, 1, 2, it only has 3 protons. So the only logical choice is B. And I needed to see, you get partial credit for choosing the correct letter and partial credit for the correct justification. Okay, so I graded all of that on 1 rubric out of 4. This question was a level 4 question, and all the others were leading up to that, all right? So that is feedback on rubric 1, constructing explanations. Actually, the rubric is called using models, I'm sorry. Anyway, because we're using models in this one. Diagram 4 is a Bohr-Rutherford diagram. We're on to the second rubric right now, and we're just dissecting this, just examining this model. All right, so how many protons does the atom in diagram 4 have? Well, look in the nucleus. 8p plus, that's 8 protons in the nucleus. 8. How many neutrons does the atom in diagram 4 have? Well, 8n, and this little 0, this little null for no charge, neutral. This is 8 neutrons. 8 neutrons. How many electrons does the atom in diagram 4 have? Well, this diagram 4, all I have to do is count the red dots. So this is total electrons. 1, 2, 3, 4, 5, 6, 7, 8 total electrons. What is the energy level of this atom? All we have to do is count the circles around the nucleus. So this is 1, 2. This atom is in the second energy level. 2. Lastly, how many valence electrons does the atom in diagram 4 have? This is different from total electrons. All we have to do is look at the outer shell. How many are in the outer shell? Well, the outer shell has 1, 2, 3, 4, 5, 6 valence electrons. Valence electrons. Moving on to diagram 5, Lewis dot structures. So these structures show only the name of the element and its valence electrons. Which of the Lewis dot structures in diagram 5 matches the atom modeled in diagram 4? So you have to look at both diagrams. Remember, this diagram had 1, 2, 3, 4, 5, 6 valence electrons. Here's how simple this is. All you have to do is look at this Lewis structure, which has 6 valence electrons. Well, magnesium only has 1, 2. This fluorine has 1, 2, 3, 4, 5, 6, 7. So it's neither of those. It has to be oxygen. 1, 2, 3, 4, 5, 6. So you need to say oxygen and say that it has the same amount of valence electrons for full credit. That is a level 3 question on the models rubric. This is the level 4 question. Here you're provided in diagram 6 with an incorrect Lewis dot structure. So here, AR in the center, looking at your periodic table, you can see it's argon. And argon, I'll even show it to you on the periodic table. Here's argon right here. All the way at the end. This is a full shell of valence electrons. Argon is a noble gas. It has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Look at this Lewis structure. 1, 2, 3, 4, 5, 6. What is wrong with the model in diagram 6? It is missing 2 valence electrons. How can it be fixed? Well, in order to correct this, you need to add 2 valence electrons. This is asking 2 questions, so your answer needs to address both. I awarded some partial credit on this. If you said, well, it's missing electrons. We have to be specific with our answers. It's missing 2 electrons, so you need to add 2. That's the 4-point question. What I will do is I will grade both rubrics. So I will grade the models rubric once on the first section, and I'll grade the models rubric again on the second section. And then what I will do is I will average them, and you'll get a score out of 4. So that's how this will go. So it will be in a 100-point summative assessment, averaged between your 2 model rubrics. I know that might be a little confusing. I'm happy to answer any questions about grading or about specific feedback to your version. But for now, that is all I have, and good luck with the rest of your virtual learning.